This is the third in a series of videos on confidence intervals for population proportions. And in this video, we want to focus on actually constructing a confidence interval. So the key is a confidence interval is equal to the parameter estimate, or point estimate, plus or minus a margin of error. So the idea here is that we want to take the point estimate and add and subtract a certain amount, and then be able to say that we have a certain level of confidence that it's within those two numbers. Now to calculate the margin of error has two elements to it. It has a critical value that depends on the distribution, and also the degree of confidence, and then it has the standard error of the statistic. Remember, the standard error of a statistic is simply the estimated standard deviation of the statistic. And the critical value, again, depends on the degree of confidence, or the confidence level. Right? So, for example, if you want to do a 90% confidence interval, it's going to be larger. This is going to be a larger number than if you want to do an 80% confidence interval. Because to be 90% sure, you have to have a wider range of possible values than if you only want to be 80% sure. Now, the standard error of the statistic depends on two things. It depends on the sample size, but it also depends on the randomness of the population, or the true amount of randomness in the model. So when you're studying phenomena which are very random, you're going to have a wider margin of error for the same degree of confidence. Let's look at an example. So in this example, you're going to survey 500 college students, and you're going to ask if they like the food in their cafeteria or not. So the true population parameter is going to be the true number of college students that like their college food. And in your sample of 500, you got 271 that said that they did. And you're asked to construct an 80% confidence interval for the population parameter. So the first thing we think about is we think about p hat, right? P hat here is going to be 271 divided by 500. Or let's do that on a calculator really quick. That's 271 divided by 500, or 0.54. 0.542, we'll say. Let's go to 3 decimal places. And then the second thing you need to do, if you notice, let's look at our problem here. Our problem here is that we weren't given the true population P, or any kind of standard deviation. So we're going to have to calculate sigma P hat, but we're going to estimate that. That's going to be the standard error of our statistic, right? So sometimes that's written sigma P hat, over hat, but usually you just call it the standard error of P hat. And that, in this case, is going to be the square root of P hat times 1 minus P hat over N. P hat is your sample proportion. 1 minus P hat is 1 minus P hat. And N is the sample size. So in this case, it's going to be 0.542. 1 minus 0.542 over 500. And you're going to take the square root of that. So let's just do that on our calculator real quick. That's 0.542 times 1 minus 0.542 divided by the sample size. And then you're going to take the square root of that. What I like to do is raise it to the power of 1/2. Same thing. And you get 0.022. So now you have the point estimate and the standard error of P hat. And now it'll be fairly straightforward to calculate the confidence interval. The confidence interval we want an 80% confidence interval. That's going to equal to 0.542 plus or minus the margin of error. And the margin of error is going to be the critical value times the standard error of the statistic. Where do you find the standard error of the statistic? That's 0.022. So what we need to know now is the critical value. And let's think about what we mean by critical value. Well, we want an 80% confidence interval. And if we want an 80% confidence interval, well, we know that the distribution is normally distributed, right? That's one of our conclusions about the sample proportion. And what we're going to want is we're going to want to know the critical value so that 80% is within the center of the distribution. So we want this to be 80%, which means we want this tail to be 10% and this tail to be 10%. So what we're going to do is we're going to find the z value so that greater than 10%, greater than that value is at 10%. Now it turns out these two numbers, one will be positive, one will be negative, and they'll both be the same exact number, so it doesn't necessarily matter. Since your z table, right? Think about your z table. Usually your z tables give you the amount to the left. So what I'm going to do is I'm going to find the z value such that 90% of the population, 90% of the population falls to the left there. So we're going to do this a little bit different. Instead of finding the z, what we're going to do is we're going to look into the middle of the table and we're going to try to get as close to 0.90 as we can. There's 0.9032, 0.88, 0.90. If you look at to the left, that's 0.903. So that's 1.30. It's not exact, but it's really close. So it's 1.30. So the critical value here is going to be 1.3. If you would have found the left-hand one, then what you would have wanted is the z-value so that it's 10%. So you would have looked on here to find to the left is 0.1, 0.01, 0.01. It looks like to me 1.09. Looks like about the same. 1.3 here, 0.968, about the same. So your critical value is 1.3 or minus 1.3. Since you're doing one plus or minus, it doesn't matter if you use the positive or negative. So your final confidence interval is going to be 0.542 plus or minus 1.3 times 0.22. Let's just calculate that on our calculator. First thing you do is you go 1.3 times 0.022. Sorry, 0.022. Let's do that again. So that's 1.3 times 0.022 is 0.029. 0.029. So you give it 452 plus or minus 0.29, and then you just add and subtract. So here we're going to do 0.542 minus 0.029, and we get 5.13. 513. And then we're going to do the same thing. We're going to do 0.542. And we're going to add 0.029. We get 0.571. And let's think about what that means. What that means is that we are 80% sure or confident that P falls between 51.3% and 57.1%. And that's how you do confidence intervals.